In traditional software architectures, transaction validation is often coded directly inside the front-end user interface. For example, disabling a button in React. This is a system vulnerability. If a user bypasses your front end and hits the backend database API directly, they can submit invalid transactions, bypass role checks, and corrupt your database state. The correct systems pattern is to enforce both permission checks and logical validation rules directly inside the semantic write-back. Definition: what Foundry calls an action type. By securing the write-back at the semantic boundary, we guarantee that no matter how a transaction is triggered, whether through a workshop app, an external API, or an automated scheduler, the securities boundaries are absolute. So let's secure our outer heaven kill. Here, under our action types, we're going to select our high-stakes transaction, revoke clearance kill switch. To secure who can trigger this action and when it is legally allowed to execute, we're going to navigate to the Security and Submissions Criteria tab on the left sidebar. So over here in the Submissions Criteria panel, we're going to add a condition. First, we establish our role restriction. So we select current user and map it to group IDs. We're going to set the operator to include and select our cleared security group. This establishes our first absolute boundary. If a user is not an active member of the security cohort, the platform will completely block them from submitting this transaction, even if they can view the form. Next, we protect our data from logical corruption. We click Add a Condition again, and we're going to select our form parameter, the operative. Here we target the status property and set the operator to is not. And herein we're going to click the static value and type exactly inactive. This prevents an illegal state transition. We cannot revoke the clearance of an operative whose status is already inactive. So to deliver a clear user experience, in the failure message box, we're going to type our custom error. If a user attempts an invalid status change, the transaction will gracefully halt at the boundary and display this exact text and refuse to commit to the database. Let's save this. Now, these write-back guardrails are active at the platform, no bypass is possible, and we've secured read access to our rows, read access to our columns, and secured our operational transactions. In our final security episode, we're going to tie everything together and explore another layer of platform-grade governance, transitively tracing data lineage from raw ingestion to the end-user application to prove our classified markings cannot be laundered.